Hey everybody, welcome back. As I mentioned in the last video, it's time to work on the alternator tensioning, belt tensioning method, and I think I've figured out what I'm going to do, and I'll just kind of give you a rough idea of what's going to happen, and I'll show you as we go along here. Excuse the noise of the air conditioner. It's like 114 in the shade outside, and the thing just never shuts off. So anyway, let me spin the camera around and kind of show you what I'm up against here. So right here is the bracket that I made originally that I was going to use to tighten the alternator belt. And so what the idea was is it would slide down, the alternator would slide down in that groove, and I would tighten a nut and it would hold it there. I'm not convinced that that's going to be a strong enough way of doing it. So what I'm going to do is I'm going to augment this idea with a tensioner device, and if I can just hold the camera and grab this other part at the same time. I just had this piece of scrap laying around just to see if the idea would work. And so what I'm going to do, get that through that bolt hole there. What I'm going to do is I'm going to make a bracket with a tensioning bolt on the bottom that allows me to pull this down, and let's get that. So I'm going to just pull on this, and as I pull down, it's going to tension the alternator. So that's going to be the part that we're going to make. I could just make it out of this piece of steel. You know, I could just put a bend in the thing, 90 degrees, weld a nut on it, and maybe that would be good enough. And I might try that, but I think what I'm probably going to end up doing is manufacturing a bracket out of aluminum on the mill. I'm going to try this first because it's way faster and easier, and if it works, great. If it doesn't work, then we'll go to the aluminum. Anyway, I just kind of showing you what's going on and what the idea is, and sort of what at least the initial plan is. You know, I'm not 100% sure this is going to work either, but we're going to give it a go and see what happens. Okay, so as you can see, I decided to try the strap of steel, and I'm just going to heat it up and put a 90-degree bend in it. I've turned the sound way down here because frankly it's noisy, and you know, nobody needs to hear the sound of a hammer on steel. But anyway, we'll get this thing bent over 90 degrees with the BFH, and once I'm happy with the bend in it, I will clean it up, take the welding, that's cold rolled steel, so I got to take the mill scale off of it, and going to drill a hole in it, and then we'll weld a nut on the bottom. And at this point in the process, I'm not sure this is going to work, but you know, it is what it is, and you know, it's the easiest and fastest way to accomplish what I have to do. You know, if I end up having to machine something different, then that's fine too, but there's no use making extra work when this could work really well. So just going to build this up and then get it to where I want it. I'll mark it for where the hole has to go in it and get that drilled, and we'll just keep moving forward.
A little longer than a few minutes later.
What I'm doing here is I'm just roughing up this surface, because when the bolt tightens down on this piece of aluminum, you know, it tends to want to mark it up like that, and I'm just worried that it's just going to kind of wear a hole in this aluminum. So what I'm going to do is I'm going to cut a piece that I'm going to epoxy. I'll use JB Weld or something on the bottom of this in steel, so that I have a really nice hard surface to tighten up against. So I'm just going to mark this little chunk of steel here and cut this out, and then I'm going to, because this is aluminum, I can't weld steel to aluminum, so I'm just going to epoxy it on. And because the force is always the same way, it's always pushing against it, the epoxy doesn't really have to have any real strength. It just needs to hold this piece of steel on there. Yeah, that's, I think, what I'm going to do. So we're going to cut this off and see what happens. Clamp is not quite tight enough. Let's see if we can't improve that a little bit. Really tight to the bench, kind of hard to grind, so I think I want to move that. Just give me a little bit more room to deal with. Oh, that's hot. There we go. Okay, the piece that's on the floor is the piece we want. And then we're going to go and clean everything up and get ready to epoxy it on. I'll just clean up the edges a little bit before we get it glued in place. Nothing serious, just make it, take the sharp edges and stuff off of it. It's easier to do it now. Yeah, I think that's pretty good. We're cleaned up nice, and we've got some smoother edges. Nobody's going to cut themselves on it. So we'll get that ready to epoxy onto this piece. It's just going to go on there like that, and then that'll give the bolt this piece of steel to push up against instead of biting into the aluminum. So that's next. Okay, well, everybody has their own way of doing this. This is just regular, everyday, ordinary JB weld, and I'm just gonna mix up a little bit to glue those two pieces together. Don't need much. Whoops, don't want to do that. Never get the lid off if you put the hardener on the epoxy. And I just use old popsicle sticks to mix it up and do it on a piece of paper, nothing fancy. Some guys have got like their nice little mixing tables and whatever, but this works for me, and it's always worked in the past, and it doesn't make a big mess, and I can throw the piece of paper away and I can cut the end off the popsicle stick and use it for the next one, and so on and so forth. The trick to this stuff is just get it mixed up really well so that, you know, you've got a good, thorough, even mixture of the stuff. And then you know, I roughed up both edges, and the aluminum's already pretty rough, as you can see. So basically all we're going to do is gorp some of this stuff on here like so. And that's probably all I need right there. And then we're going to attach this piece of steel to it. And kind of use a little bit of the excess to just kind of fill in the overlaps there, and just make it a little bit sort of extra strong. Making a bit of a mess, but I can clean it up before it dries. And there goes the air compressor. So that's about it for this until it dries. We can't really put it on the car or anything yet, or on the engine. So we're just gonna let that harden up and see what happens.
24 hours later.
Well, it's the next day, and our JB weld has dried overnight. So now I can just take a file and clean this up a little bit and smooth things out, and we'll give it a test fit and a try on the car and see what happens. So here's maybe something some people don't know is you can file and sand JB weld after it's hardened, and you know, just kind of smooth it out and make it look a little bit better. Not that what this looks like really matters to anybody but me, but it's just a nicer finished piece. And so what I'll do here is I'll just kind of sand that out and kind of make it smooth and get it looking the way I want it, and then I'll take this over to the other bench and just kind of sand the whole part and take the scratches and stuff out of it that I've put into it. And again, nobody's ever going to see it, nobody's ever going to know except me, but you know, that's just the way it is. And you know, I like it. I like to know that when I make a part, it's a part I could show somebody and go, hey, I made that, right? So, but as it turned out, if you look on the bottom, this is the steel piece that I JB welded on. So now when I tighten that bolt up against this, it's a nice hard piece of steel. So we're just going to take this and sand it all smooth and make it look pretty. And then final step, I might just take it over to the blast cabinet and give it a quick bead blast just to take the sanding marks out of it, but we'll see. It's not super critical, but we'll just move over here and I'll fire up the sander and kind of just give this a bit of a go. This is just 400 grit sandpaper. It's kind of hard to hold on to. I think what I might do is just clamp it down so I don't have my fingers in the way. Maybe there's a little bit more pressure than that. Okay. Yeah, pretty smooth. Just a little better. Do the same thing to the other side. Just kind of clean that up. Okay, so you can see it looks a little better. It's a little bit smoother. I could clean this up maybe even a little bit more. I think I will. But yeah, we'll just keep working on this and kind of get it where we want it. It's fine the way it is, but I'm just going to clean it up a little bit more. Yeah, good enough, I think. Okay, so I've got the parts installed, kind of mocked up. You can kind of see it in here. This is the part we made yesterday, welded the nut on it with the tensioning bolt in it. And then from the front, looks like that. You can sort of see what's going on. Take you up under the belt, right? So this is the bracket we just polished. The bolt goes through that, and then this is the tensioner part that we're trying to install. So I'm going to bring you back and set you on the tripod and kind of adjust the belt tension, and we're going to see what happens. Okay, let's tighten our adjuster down. These other bolts are just finger tight, and there's just a nut on the back of this just to hold the bracket on for the time being. But this is just basically a test to see if the idea in principle is going to work. So when we tighten, yeah, you can see the belt is getting tighter, and the distance is growing between here and the engine block. Oh yeah, we can get pretty tight, pretty snug belt there. and probably gonna have to put a lock nut on here just to hold it once we get it tensioned, but yeah, we can get that belt plenty tight. So I think that's gonna work. So now what I'm gonna do is I'll take this bracket that we made off and clean it all up, sand it, and probably give it a coat of paint and just you know, make it look finished. And we've got that problem solved. But then the next issue that I noticed is when we started tightening the belt, I noticed that this is kind of moving right here. Like, it doesn't move much, but it kind of pulls a little bit. And so what I think I might do is manufacture something to make this more structurally rigid. So I've got to come up with like an aluminum bracket that I can make on the mill for that, but now we'll cross that bridge when we get to it. For now, I'm going to finish this other bracket for the tensioner. All right, I think we're good to shoot some primer and paint on it and call her done. Okay, so we have the tensioner made, and now I'm going to make the brace that's going to support the front of the alternator, you know, mounting bolt, the one that, you know, sticks out 2 inches past the motor plate. And so what I've done is I've just taken a piece of aluminum stock from the shelf, squared it up, and I've done a rough cut of the piece that I'm going to use, which is this piece right here. And so the way this, I think, is going to work, and keep in mind this is just rough cut right now. We still have to get all the dimensions and stuff, but on the back of this there will be 2 threaded holes, and then there'll be a pair of bolts that come through here. This will bolt onto the motor plate like that, and this piece, this front little step or whatever you want to call it, will have a hole in it, and we'll eliminate this spacer, and this will go in its place and bolt up to there. It'll fit down tight to the top of the alternator, and hopefully it'll prevent it from doing any, you know, twisting or moving around when we tighten the belt. So that's the goal. So now what we have to do is clean up the dimensions on this, get it dimensioned accurately, make it fit good, drill a hole in it, then clean it up and make it look like something. So that's the next step. So we're making the brace for the front of the alternator bracket, and I just wanted to show you a little bit of the setup in the mill here. I'm not going to video the whole manufacturing of this thing. I think everybody's seen how a milling machine works, so we're going to finish putting the correct dimensions on it, and then we'll put a hole in here for the bolt to go through and just kind of clean it up. And I'll kind of show you when we get closer to bolting it on the motor plate. We'll come back to it, but I just wanted to give you a quick peek at, you know, just how this is getting made, and maybe one or two steps along the way I'll shoot a few seconds of video just so you can kind of keep up with it. So anyway, that's it for now. Okay, well, we basically got it made to dimension. So this is going to fit on here like this, and it's exactly 2 inches, so that part of it fits really good. So now what we have to do, we have to put 2 holes in here and thread them so that that can bolt on to the engine plate. Engine plate goes here, bolts will go through, this will bolt on, and this will kind of be like this, and then the engine plate obviously is right there. So we got to do those 2 holes, and then we have to do obviously the hole through here for the alternator mounting bolt to go through. And I rounded the corners and stuff just to make it look a little nicer, and I'm going to round these corners too, but probably not going to do this on the mill. I'm just going to hand file this stuff. This doesn't have to be, you know, anything crazy, but I'll just round the corners off and just kind of make it look nice. So now I got to find the center of this, or at least the center of where that will be when it's mounted. And I'll probably just use a transfer punch through here. Find that, and then I'll drill that hole, and then just start finishing up the edges, and then put the 2 holes in here, thread them, and we should be good to go. So it's coming along, but you know, I've probably got 3 hours into making this thing. Time flies when you're having fun, right? Anyway, we'll keep on going. Okay, well, we got the hole drilled in it, and fits nice on the alternator. So now all we have to do, I think I'll probably put it in the blast cabinet and just give it just a glass beaded finish to it, and then got to drill 2 holes in the motor plate, and then the corresponding holes in here, and then thread these holes, and this thing will be ready to mount on. So yeah, a little bit of whittling around, and turned out fairly well. You know, I mean, for a homemade piece, it looks fine. You know, I don't think anybody will think I bought it someplace, but for, you know, doing it yourself in the home shop, I think it turned out just fine. Well, so there it is. It's bolted on. It's bolted in from the back. There's two 1/4 20 countersunk screws that hold the bracket on from the back, and everything seems to work pretty good. I've got the belt tensioner all in place, and that seems to be working really good. The belt's good and tight, and now when I squeeze on this, the front of the alternator is rock solid. It doesn't move around like it used to. So this little brace is doing some good stuff. This should be really solid. One less thing I've got to worry about going down the road, you know, from one racetrack to the other or whatever. So yeah, not exactly sure what finish I'm going to put on this yet. I think I'm just going to make it match whatever I do on here, so I'll figure that out when we get there. So like everything else, now that it's all put together and working, I get to take it all apart again, and I've got to finish this, and I've made sure there's clearance for the coolant hoses, the manifold, and everything that goes on here. Made sure that all fits, and yeah, so far everything looks pretty good. So fingers crossed that we can move on now to something different, and just keep plugging away and making progress. So as always, thanks very much for watching. Like, comment, subscribe. I'd love to hear from you. If you have a better way to do things or questions, whatever, feel free. It'd be great. So again, thanks for watching. I appreciate it, and we'll catch you next time.